The Sporland division of Parker Hannifin Corporation is sponsoring this podcast. Sporland is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporland maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, Zoom Lock Max Press to Connect, and Zoom Lock Push to Connect refrigerant fittings. If folks want to learn more, what do they do?
You can go to sporland.com.
I guess that's Jim and John for Sporland signing off.
We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of the day or night to check stock on your favorite brands, such as Copeland, Sporland, Carlisle Compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann Parts, and Co2. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
What's going on, everybody, and welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel and Kevin Compass. Where are you at today? Are you traveling afar? Are you out of state? Are you in Ohio?
No, I'm not in Ohio. Thank God. No, I'm back home. We kind of just popping in and out and knocking some jobs out. We changed some compressors that weren't bad. And
What?
Oh yeah, well, one of those brilliant, like, we're gonna upsize these compressors. I go, well, one of these compressors is the same compressor that was already there.
Come on.
Yeah, that wonderful engineering company that everybody loves.
Oh, that one.
I'm like, you know what? I'm not even gonna argue this. I'm just gonna change it.
So wait a minute. They thought they were upsizing it, but they changed it out to exact.
Yeah, because it was already upsized on the last remodel.
So they were looking off when they did the quote. They were looking at an old refrigeration schedule that didn't have the updated compressor, right?
Mm-hmm.
Well, I guess who needs as builds, right?
Meh. Who am I to question an engineer?
Sweet.
So the other one we had obviously retrofit and it ended up going from like a 1.1 suction to 2 1/8.
Oh shit!
So we had to blow a hole in the header, and of course, like, I was choking to death, and we couldn't use a T-puller, so we had to use a hole saw, and it was on an angle.
Was there a big fireball when you finally started trying to braze that shit together?
Actually, that was not the problem. There was like no oil at all.
Wow.
It was like the fact that the ball valves wouldn't hold all the way, and we had the vacuum pump going, and 2 Milwaukee fans and the rack exhaust fan that was right there. I was choking to death.
So I have a question for you then. So was this a bottom stub up, or was
Top
it
stub up?
top? Okay. So let me ask you a question then. So what do you do as far as oil return? Because obviously when the suction is placed in the bottom, typically there's a small little weep hole, that, you'll stick that piece of pipe up in, let's just say the header is 3-inch, right? 3 1/8. And, you might go halfway up, and then cut it at an angle, that piece of pipe that you're sticking up, and then drill a small, like 5/16 hole, usually about a 1/2 inch up from where it's going to end up lying. And if you're doing top mount, right, if you're doing right at the top of the suction header, then you have to have a 3/8 line, sucking from the bottom there, that's going to go up into there, usually before the filter housing. But what did you do?
Yeah, I piped it like it was before. There was no 3/8 line. It was none of those racks. There's hundreds of those hill racks out there.
Oh, okay.
None of them they're all top fed, and they're kind of on an angle, and they're in like 1.5 inches, and then that's it. So I mean, big header. So I usually cut mine a little bit at an angle, and then I'll just take the bandsaw and just kind of like whack it on an angle, and then just clean it up real good, and then I'll just burn it up. Obviously, we had to use a hole saw, so we had to gap it. So you had like a 1/4 inch gap on one side because it's on the angle on the header. Because I mean, 2 1/8, you only get so much room with 2 1/8. So where it ends up and where it ends up, where it's straight and not going to put stress in the pipe. But yeah, I choked to death for like 10 minutes until we got it like 90% burned. Right. It was just, and it wasn't even like it. I mean, it held like down to like below zero for like 5-10 minutes. It was just something was weeping, and it had to been close because it was just one joint too. So it made it even worse. So it was like just muster through it and try to get it done.
I've had that happen where we had to change out a suction to liquid heat exchanger. So you had like 1 5 inch going in for the liquid, and it was like it had to be 2 5 because we used the big bastard, the big torch in order to braze off the 2 5 because the heat exchanger, it's fucking steel, so it just wants to eat up all that heat. And man, it was sealing for a while, and then all of a sudden just start choking to death because something decided that what, yeah, I'm done holding. And we actually pumped everything down. It was one of those racks out there that typically has a remote header that has just a shit ton of gas and the the liquid lines and all other. And I got everything pumped down, but main liquid somewhere just said, "Go screw yourself," and I'm just gonna keep bleeding.
Yeah, that is the worst. Is like it just like you're good, and all of a sudden it's just like, oh shit, here it comes.
Yeah, like you don't know where the hell it came from. Like it was holding 5 minutes before when you had everything cut open. Because obviously when you do a job like that, you want to fit it up before, just to make sure you're not, trying to do everything in a rush and then candle wax your braze trying to get the freaking thing together because you're freaking out because something's not holding. So, but yeah, fun times.
Then I jumped out of there to go help get a CO2 startup ready that we're kind of rushing to get done because we're up against the deadline, and the rest of the store is not ready, and they're screwing us. So, we're setting evac units on lag bolts because they're no concrete's done. just craziness. Awesome. Well, I mean, that's what we do. Like, I mean, if the concrete's not done for the evac pad, we shoot Tapcon anchors in the ground like lags, and right where we know the concrete's going to be, we'll use like 8-10 inch lags, and we'll screw them down, and that way the evac's sitting on the lags, and then we'll pull. They can pour concrete around it, and we just got to lower it down a little bit and just sit and flush.
That sounds fun.
Yeah, so we're getting that ready. So hopefully Thursday and Friday we'll be firing that up. For once, a CO2 storage that should go easy. I just screwed myself, but
nothing's gonna hold now. No, I'm going out to do some in-person training tomorrow down at one of the stores, and I was working on slide decks all morning and afternoon, and it was good for a while. And like I kept poking into my email, make sure nothing important came through, and then I hadn't checked it for, I don't know, probably about a good 3 hours. Then all of a sudden I look and I have 25 new emails that all need attention. I'm over the emails. I really am. That's one thing I really don't dig about my job.
I just stopped looking at them after a while. I'm like, you know what? There's like 30 there. I don't care anymore. This is like, you just can't.
I mean, you can. It's just, yeah. It's just tedious. It gets tedious after a while. I think that's it. So, but, yeah, we were going to talk about, talk about CO2 a little bit. We were going to talk about the HPV and the BGV, and the HPV is not the one you're thinking of, the human papillomavirus. It's the high pressure valve that's on the drain leg of the gas cooler. So, yeah. Anything you want to start off with, boss?
So we'll go over why do we need this. Okay, so we've gone over in other episodes how CO2 works. I'm not going to super deep dive into that, but why do we need these valves? Okay, so why is this different than normal refrigerant? So CO2, when it gets above 87 degree condensing temperature or 87 degrees, it is no longer has a PT relationship, meaning it no longer shares a pressure temperature relationship. So as the pressure goes up above 87 degrees, that relationship no longer is a linear line. It's could be anything. It's an unstable fluid. It's transcritical. So when we're above that, CO2 becomes incredibly inefficient. So that is a liquid vapor mix, basically. And if you were to try to cool with that high pressure, unstable fluid, the cooling properties of that is extremely poor. So your cooling per pound circulated would be terrible. So it would be completely inefficient. So what we do with this is we have to bring that CO2 back down to a stable state. So we have to bring it back down to a stable, workable state. So the way we do this is we need to bring it back down below 87 degrees. So how do you do that? Okay, you either have to reduce the pressure or reduce the temperature. So you have to bring that pressure back down to a stable point. So what we do is we play this fine balancing act with this high pressure valve. And this balancing act is, okay, we're going to hold back a little bit in the condenser, but not enough where we're going to trip on high head or raise the head pressure, through the roof. And we're going to restrict the amount of, return gas / liquid going into the flash tank / receiver, so we could reduce the pressure on the other side of that valve. Because what we want to do is, as we lower that pressure by holding back, we're, essentially letting that pressure on the other side of that valve come down with the use of another valve, which we'll go over in a second. We're letting that pressure come down, and we're flashing that unstable transcritical fluid, it's a liquid vapor mix, back into a usable liquid refrigerant that is subcritical now. So meaning it has a much higher cooling capacity than it would if it was transcritical. So it's a fine balancing act with this high pressure valve. So it's holding back to a COP setting. So inside of whatever controller is controlling it is a COP chart. So COP charts exist for every refrigerant out there, for compressors, for everything. It's a coefficient of performance chart. So the problem with CO2 is above 87 degrees, that chart is no longer, a good reference. So because it doesn't share that pressure temperature relationship. So what these manufacturers have come up with, Danfoss, Emerson, Carrel, RDM, Microthermal, they've all been like fighting this fight, and they've all think they have the COP chart where they think it maps out, where they think it is, it may share a pressure temperature relationship. They can't really tell, but like they have this chart with their pre-programmed algorithms in there where they think it is. Everybody's a little bit different. I'm pretty sure most of them are probably the same, and half of them probably stole the algorithm from each other. I mean, but they're constantly in the COP chart. So what they're doing is they're trying to maximize this condenser operation by holding back and trying to keep a subcooling number, what they think it is. So drop leg temp minus whatever the saturation will be on the COP chart that they have in there, which you're never going to know what it is because, I mean, it's so hidden deep in the algorithm. We as technicians are never going to be able to see it. So what they're doing is they're trying to maintain a subcooling number, magic made up number on this condenser / gas cooler, because it's a gas cooler now, because all we're doing is rejecting heat. And they're trying to maintain this magic subcool number to keep this condenser running efficiently and at the same time not trip on high head, but also reduce the pressure in the receiver. So this valve does this like balancing act. And it's, if the pressure gets too high in the gas cooler, it'll start opening up a little bit. If the subcooling is too low in the gas cooler or the pressure is too low in the gas cooler, it's going to hold back. So in the winter,
wait a minute. Not only is it trying to achieve a certain subcooling, but what it sounds like it's trying to achieve a certain pressure as well. Is that correct?
Correct. You're trying to keep it. You have a limit in there. You're trying to keep it below a certain limit. It's trying to. You'll play this balancing act of, okay, like I want to say your max threshold's 1,500 pounds. If it's holding back and it's the subcooling's low and it's holding back, trying to raise that subcooling, and it doesn't want to hit, as soon as it starts to hit that limit, it's going to start to open up to allow that pressure to come back down.
Because that's where the confusion is, because you also have the gas cooler that's essentially usually set for a 5-degree TD, because most of them are the Abatic, right? Whether it be the Gunter, whether it be the BAC, typically either the 326 or the iPro or the Corel controller are typically set for anywhere from 3 to 5 degrees of subcooling, right?
Yeah. So, I mean, most ours, we just started getting Abatic up here. Like most, probably out of the 50 stores in Chicago, they're all air cooled.
It's hotter down here.
Allegedly.
You were down here. Don't give me that allegedly shit. How do you live down here besides the barbecue?
Yeah, the barbecue is good. So yeah, I mean, you have this fine balancing act you're trying to maintain. That's where this valve gets confused. Everybody thinks it's something it's not. So this valve is just doing what this controller does. So it's a holdback valve. Think of it like a holdback valve, and it's trying to hold back at the same time. But it's just doing what this driver is telling it to do. Now, there is a couple different kinds of high pressure valves. Sporlan and Danfoss are the only two manufacturers that I know of that I've seen that make these. So Sporlan makes a high pressure valve, and Danfoss makes a high pressure valve. Now, Danfoss's are CCM valves or CCMTs. Sporlan's, I'm not sure of the nomenclature. I think it's I think they call it a HPV, high pressure valve.
Yeah.
So what they're doing is you have a couple different options here. So Danfoss has a stepper motor on theirs. They have one with a CCMT which is a stepper motor driven valve. So it would be a bipolar stepper motor. So it's getting a bipolar signal, an open and closed signal from a 326A, a iPro controller, whatever is driving that. You could be using the E2 to drive that. I've used the E2 to drive a high pressure valve, a multiflex board. So that high pressure valve is just doing it. It's a dumb valve for the most part. It's just doing what it's told. So it doesn't know what to do until it's told what to do. So that valve is just driving on how it's supposed to be driven. Now, Danfoss also has a magnetic actuator that goes on top of a CCM valve. To be honest, I like this valve the most. It is very low. It has a low failure rate. It's very easy to work on, and it gives you a feedback signal, and the valve knows where it is in position. So it has a feedback signal. So not only where you're telling it, you're sending it a 0 to 10 volt signal to drive. So say you could do it either or. You could do it 10 volts full open or full close, depending on how your control system's set up. you could tell it, okay, I'm calling for you to be 100% open. It also has a feedback signal of where the actual magnetic valve is. So it could say the feedback's only at 30%, but you're commanding it 100. Well, it may be because you're limited on the valve position, or it may be that your valve is stuck. And then you could see that. I like that part of that driver a lot more. Go ahead, Brett.
So it's comparable. Let's think it in this term. Like if you had an economizer, right? Typically, we try to drive an economizer damper to 0 to 100%, 0 to 10 volts, and let's just say we commanded it to open up all the way, and it doesn't go all the way. Maybe it gets stuck halfway because the gear's messed up. Well, the feedback loop, yes, we're sending 10 volts to open the thing up, but on the feedback loop, it'll say, hey, whoa, something's up. I've only got 5. So that's what Kevin's talking about, just to elaborate just a little bit.
Yeah, so the feedback loop is, giving you a reference to where that valve actually is. These high pressure valves all have a strainer in them for the most part. I don't know about the Sporlins. I'm assuming they probably do, but the Danfoss for sure have a strainer in them, and they do get dirty. So it is like our deal on startup now. We let it run for like 72 hours, and then we'll pump it down, and we'll clean the high pressure valve strainer right away, because these racks, if you do not purge stainless while you're TIG welding, you get what's called sugar dust inside the pipes. So it's like crystallization from the rod and the actual stainless process. So it's like way finer, nastier than like braze dust. So like if you're brazing without nitrogen, and let's be honest, like some of these tanks that are in these are just like filthy dirty. So, I mean, you don't really know what you're getting. We pump these down, and if you start seeing like high pressure valve percentages, like if you start seeing them in the 90s, 100, like there's a problem. I mean, and it's probably plugged up and has reduced flow. Go ahead.
Even if you have a loaded up rack, what's the max percentage you've ever seen any of those valves actually running at? I mean, unless there's an actual problem.
So a Hill Phoenix Aldi usually is like around like 90% on startup, like when it's, pegged out, but most of the time 50%. Like the targets I've started up have been limited to 80. Like they can't even open more than 80.
Because then it dumps the pressure down. I was talking to someone today. I think he was actually working on a Kaiser rack. I think yes, but he was having a problem where he had lower pressure, on the flash tank, and he had the valve was barely opening for the HPV. So we decided to try this and raise the subcooling from 5 to 3. Because then, it would basically the HPV would want to open up more, and he got more load. I mean, he's starting up the rack, so he doesn't have everything all loaded up, and there's still a shortage on CO2 if no one's aware.
Yeah. Generally when I see that, it's the bypass valve bleeding through, or it's not zeroed out on startup, and it's wired backwards. Most of the time it's wired backwards. So that usually ends up causing it to drive down. So now that we have this high pressure valve, and we have this balancing act going on where we're holding back, and we're trying to maintain that subcooling at the same time, we're trying to maintain that receiver pressure from getting too high, and or the condenser pressure from getting too high. That's all in the parameters. Now we're going to move on to the bypass valve. So what you have now is we need to reduce this tank pressure even more, and we need to do it faster. What we do here is we have what's called a flash gas bypass valve. So it can be called a flash gas bypass valve, economizer line bypass valve, FGB valve. So what this valve's purpose is one and only purpose is to maintain receiver pressure. So the way it does this is by venting your medium temp. So by venting the flash tank into your medium temp suction. So what it's doing is it's constantly pulling vapor off the top of the tank, and it's venting it to the suction header. So what it's trying to do, so say you have a set point of 500 pounds in the flash tank. This flash gas bypass valve is constantly pulling vapor off the top of that tank to maintain that tank at 500 pounds. And then your high pressure valve is constantly opening and closing, allowing pressure to come in. Go ahead, Brett.
So since you're talking about, we moved on, unfortunately, but I just thought of something. Like let's discuss where the placement, because yes, we know that there's a controller. We know there's either a Danfoss, iPro, whatever, hooked up to this to control the HPV and the BGV. But where is the sensor placement? I believe that the up for the HPV, the sensor needs to be right on the drain leg, right? What 12 inches out from the bottom. And the same thing with the sensor, right? With it insulated, and they also recommend that you seal it up with reflective tape to make sure the weather doesn't hit it, right?
So the sensor, usually 6 inches. I've seen them 100 feet away, and I've seen them work fine.
Really?
Yes. All the Costco's and all the Targets are at the rack, not at the condenser.
See, all the ones that I've seen have been on the roof. So the condenser and the racks right next to each other. So it's like right on the outlet, the sensors and the pressure transducers for the
pressure transducer is always at the valve, and the valve's always at the rack.
Gotcha.
So, but the temp sensor, I've seen it both ways. I've seen it where Danfoss wants it six inches from the T is where they call it, where the condenser's T to get gas cooler T's together is where they want it. Now, in a perfect world, that's where it should be. But when the rack manufacturer sends all this out pre-done and it's not in the prints, it's where it ends up being. As long as you're insulated good, I don't see much loss of performance.
All right. And then the BGV, that pressure transducer, is going to be on the flash tank because that's what we're trying to control, right?
Correct.
And basically the BGV acts, the same thing as the HPV, where it's an inlet pressure regulator. I mean, that's what it's trying to do, right? It's trying to relieve the pressure. If the pressure gets too high, it opens up and relieves that pressure into the medium temp suction, which is running 4 to 420.
Yeah, about that, depending on what you're running, what your target is. But it's so you have a flash tank at 500 pounds. You may have a medium temp suction at 400 pounds. So you have that big difference there. So that valve doesn't need to open up very much, 20%, 30%. Now that valve's whole thing is the opening percentage is going to change over time. I mean, obviously, if it's hotter out, that high pressure valve is going to be doing more work, and you're going to have higher pressure coming into the tank. So you're going to have to vent more off. Now, as you vent this off, what you're doing at the same time is you're reducing the pressure by venting it, and then it's also making it colder. So what happens is you have that liquid, that volatile, transcritical fluid is now turning back into liquid. Unfortunately, this is a very unstable liquid just due to the process, because you have very low subcooling when it's warm out. So, I mean, you may be lucky to get a degree of subcooling out of this tank, out of the receiver. So, I mean, that's why the liquid lines need to be really well insulated. And the fact that they're going to be running most of the time 33 to 35 degrees. So your liquid lines are. Go ahead, Brett.
I'm assuming that's why a lot of those cases have heat exchangers inside, right? To try to help get any additional subcooling it could potentially get.
So twofold. So they're robbing Peter to pay Paul. So they're trying to get a little bit more subcooling, and they're trying to keep any liquid from coming back to the medium temp / low temp. So yeah, they do help. So they like Brett said, there is heat exchangers, or they make their own heat exchanger to weld the lines together. Stop it! Don't laugh. So that's a proper way to do things.
You realize how much more time this takes me when you do that, right? You're doing that on purpose.
You did it first. But it's that fine line we're walking. Okay. So now we start adding these two valves together. So you got one valve opening, one valve closing constantly, one valve closing, one valve opening. So as the flash tank bypass valve closes down a little bit, the pressure starts dropping, the high pressure valve starts opening, to start filling the tank up more and keeping the pressure up. So these two valves have two different PID loops that are working together. So they're constantly looking at two different things. So this controller has to have a flash tank pressure transducer, a drop leg transducer, and a drop leg temp sensor to work. It needs these three things to basic bare bones, bare minimum for this thing to work. So it's taking there, and then it's constantly running this algorithm to kind of maintain this tank pressure and subcooling / efficient efficient gas cooler pressure and temperature. So it's constantly walking this fine line. When it's cold out, you run like a freight train. I mean, these racks thrive when it's like 0 degrees outside.
All right, guys, we have question number 1 for the month of October. What is the HPV supposed to be programmed for as far as the amount of subcooling? Let me know and send your answers to arpgiveaways@gmail.com. Thanks and good luck.
Hello guys, this episode is brought to you by Fieldpiece. Fieldpiece's next generation of vacuum pumps will cut down on evacuation time and make oil changes on the fly a breeze. They are lightweight, durable, and feature 4 inline ports plus a large oil reservoir. Get pumped about these 3 new Fieldpiece vacuum pumps available at distributors now. Learn more at fieldpiece.com or follow us on social media at Fieldpiece Products. Thanks again, and thanks for listening.
Hey guys, today's episode is sponsored by Westermeyer Industries serviceable oil floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode.
Because, I mean, that's less load in the flash tank, because now your flash tank, your drop leg pressure is coming down to a minimum. Say you may only be running 650 pounds. Okay, so now it only has to drop at 150 pounds. Say your pressure is 500 pounds and you're dropping at 150 pounds. So that flash gas bypass valve may only be pulling 5% off the top of that receiver / flash tank. So go ahead, Brett.
So when what I'm getting then is that when it's running transcritical, you're going to be using more energy, right? Because you're not making like a really, really, really good liquid coming out of the HPV. So because you're having to flash off more liquid that's down at the bottom of the flash tank already to achieve a decent subcooling, there's more energy consumption there. Where if you were making straight up liquid when it was running non-transcritical, right, you're gonna end up saving money when you're running subcritical, not just because of the compression ratio, but the quality of the liquid as well.
100% correct. So like when it's hot out, transcritical racks are extremely inefficient. I mean, you're running a lot of horsepower to pull off there, to pull that vapor off there. I mean, we have a couple racks over here where it's like 2 compressors are just dedicated to flash tank load almost. And I mean, that's a lot of horsepower. But then when wintertime hits and we're running drop leg temps of like 28 degrees and it's like straight up, like just frosty, like drop leg temps, like EnviroGuard style. And we're running like super low head pressure and really efficient liquid. I mean, we're barely pulling any vapor off the top there. And this thing's just running like a top hat.
So one of the things I've noticed is, unfortunately, with all the extra stuff that you have to do, that there's a lot of extra control. And that's why, like, dealing with and getting these racks tuned, with these 2 valves is kind of a bitch, because there's so many different set points. You have to tell it when it's technically transcritical. You have to tell it, what your subcooling is when you're running in at subcritical mode, and then you have to tell it what it's going to run when it's in transcritical mode. So there's so many set points, not just for the HPV, but for the BGV as well. I mean, I was reading through the 326A manual last night because got nothing else better to do, and I was bored. But I started reading that, and I went through like literally every single set point, and there's at least, besides like amount of steps and stuff like that, there's like probably 15 or 20 different set points that are going to affect the operation of both those valves.
Yeah, 100%. And then like you look at the iPro, it's even more confusing at some points. So
I'm looking at it now, like it's the BGV band offset, BGV proportional band, BGV integral sampling time, BGV derivative sample time, BGV derivative time. Like it's so many set points. It's retarded.
So, and then I have yet to see a rack come out from the factory that's even tuned, like remotely close. I mean, so like this all has to be field tuned, and like you get a base, but then you have to tweak it. Like there's every store is slightly different. So like a store, say that you have the same exact cookie cutter store, you throw that store in Texas, the same settings, they may be close, are not going to be, run as efficiently as Indiana.
Not just that, but you can't assume, what increments it's in, because, at 326 and the iPro are both in bar and degrees centigrade. So I'm looking here, I'm like, well, why is the subcooling set point in subcritical mode only 1.7? And I was like, oh, wait a minute, that's 1.7 degrees differential centigrade. So that's like three degrees or something like that.
So yeah, the only thing nice about the iPro is when it goes to D2, it switches to pressure.
So, what? Oh, it does. That's right. Yeah, I saw that.
It converts it back over to pressure instead of bar. So, I mean, just be very mindful that you're not downloading or using some weird bar calculator, because I had this happen to me one time. I just Googled bar calculator and didn't realize it was off.
Figuring an absolute?
Yes. I didn't realize it. I mean, when you're talking like 14 pounds, PSI, like it's really not much when you consider like, okay, it may be
but
5 pounds.
But it's 1 bar per 14.5
yes.
PSI. So it's incredibly high if you have too many bars.
So yeah, that'll screw you over. So I mean, when you're going through these, I mean, the manufacturer's going to give you something to start out with. Okay. But that's a starting point. Tune it yourself. Make it work better. I mean, mess with the PIDs. Make it, just little increments. So that way it runs better. Now, I will say this. Microthermal, hands down, has everybody beat. Like, their settings are 1,000 times easier to tune, and they have winter and summer settings. They're the only ones that do it, and you have winter and summer settings. You could change, like, so when it's running subcritical, it has a different set of PIDs. It's more complicated, but I like it.
You could do that. There's different ways you could do that if you really had to.
26 or the iPro.
No, but
change it manually.
No, but what you could do is you could have not the summer one. What you could do is you could change the set points in the condenser based off of a ambient value. No,
but like I could change the ambient set points for the condenser fans. Mm-hmm. I could change it to where it runs off pressure or temperature, depending on the weather, and I could also change the PID sets. Which is a big thing, like being able to change the PID sets. I have a winter's PID set and I have a summer PID set. So you could fine tune that even more. You could make it be more aggressive in the summertime so it doesn't get out of control, and less aggressive in the wintertime. So that way you cut down on your wearing out the valve.
Gotcha.
Bad tuning kills these things. So
you're talking just straight up rack control, bad tuning.
Well, bad tuning even on the HPV and BGV controller. So whatever you're using, if you're using a standalone controller, like usually it's the flash gas bypass valve that wears out first, because it's the one hunting the most. So generally that one will wear out first, and just basically like the Danfoss valves will just fall apart. Like they'll just the screws will just come apart on the motor. Yeah. I have like 3 of them in my van that they were all a year old. The screws all came apart from the motor.
Really?
Yep. All same failure, common thing. So I mean, some of them I've been changing them to CDS valves. The manufacturers said they had certain manufacturers they had a failure. I'm going to be honest, I haven't lost a CDS valve yet.
You just figure out what well, I
Yep.
mean, you just figure out the size of the valve that was in there and then change it out with a Sporlan CDS valve.
Yep. Generally a CDS 7 or 4. I mean, I haven't seen even a bigger rack. I haven't seen bigger than a CDS 7.
Thank you, Sporlan.
Yeah. I mean, they end up working good. And the problem with the Danfoss valves is getting them. Because the only one that stocks them in the US is United. And everything is like just kept by these OEMs. Like they have the entire supply.
You remember when we were trying to find orifices, right?
Yeah.
They couldn't even give us a number. Like, well, how does the manufacturer not know?
Yeah. I mean, everything is just kept by the OEMs. So, I mean, they're all stockpiled. I mean, they're the ones buying all this. So, I mean, yeah, United can get you one, but I mean, they're going to have to get it from Danfoss probably because it's hard to get those high pressure valves right now. Like it's generally not a stocked thing. You probably have to go to an OEM.
Well, listen, if anyone knows what the new control, so Kevin and I were talking. So the 326A apparently no longer exists. So if someone has an idea which pack controller that Danfoss is using to control that new thing, let me know. Just curious.
It's a 5 something, 7 something, or a 6 something something.
So hold on. A 5 something or a 6 something.
I don't know. They got to make their part number so difficult. I mean, I'm going to be honest to you. Like the last 3 racks we started up had iPro controllers in them, and I'm going to tell you, I absolutely fucking hated the iPro controller when it first came out.
Was it because you couldn't get to all the settings because the description file didn't have everything?
It was that, and then it was very slow to update. Like even the screen was very slow to update. And it was causing issues with blown reliefs. Like I was on 3 different startups and the OEM ripped it out and put a 326 in. Like they made the decision. They're like, yeah, we're not using this. We're going to 326. Yeah. So I'm going to be honest. Like I was apprehensive at first. We did the first one in Wisconsin. It ran great. I mean, we had a little bit of trouble getting it online with the E2.
Yeah.
Other than that, it ran good. The stock settings were pretty good. We had to tune it a little bit, but I will say this: there is definitely some kind of comm issue.
Why is it dropping out?
It's not. So if you look at the graphs on the E2, it looks really good. I'm like, holy shit! I'm looking at it like that graph looks too good.
Yeah.
I'm like looking at it, there's a lot of straights.
Low sample rates.
Well, it's either low sample rates or it's. So I was watching it the one day, and it's online, offline on the screen, online, offline on the screen, online, offline on the screen. It's like 30 seconds on, 30 seconds off, 30 seconds on, 30. I'm like, what the hell? So like I move it to a different port, and it's on its own. I figured maybe there's a bunch of traffic from the other core links, from the Husband stuff. I figured it was a bunch of traffic, so moved it on its own port. It's on its own dedicated wire. Still doing it. So I'm like, okay. Like, honestly, I think it's maybe a customer like baud rate issue because they're running at 9,600.
I don't agree with that at all. I think everything should be. I think everything that's passing that much data should be
19.2 or
19.2, yeah. So
I'm
actually looking at the E2E configuration right now. Do you have the polarity swapped? Because okay. I'm just asking because it shows that the polarity is swapped from the E2E to the the core link controller or the iPro.
Well, here's the thing: if you look at the E2, it's never offline. Only on the screen visiograph will it show offline.
And both the grounds are not hooked up, and they actually have a 100 ohm half watt resistor going right to ground.
Yep.
And you have the terminating that big freaking black brick.
So we have the whole thing set up how they have it. I think one of them racks has the brick, one of them has a resistor. That both manufacturers are doing it different, but they're all doing the same thing. So I talked to another guy. So one of my guys is doing them. He's like, shit, the two I just did were doing the same thing. So the graphs look great, but it's a lot of straight lines. When you see straight lines and graphs, generally that's a data issue. I mean, you're not getting it's stale data. Then I noticed the core links do the same thing. The core links,
I think because the sample rate, I think I'm like 100% positive that certain customer has a sample rate of like 5 freaking minutes.
I don't know. Like,
I mean, that would explain it.
I mean, yeah, it would, but I mean, the popping off the line, like if you look at the core links sometimes on the E2s, especially in these CO2 stores, like there's a lot of flat lines. So you're like, shit, that's not a good graph. That's just a lying graph.
Yeah.
I mean, it's a lot better. Like, I mean, we tuned it a little bit. We're watching on the Visiograph screen. It does look way better. And it is quite easy to set up. I will say this, that was quite frustrating is figuring out the enable signal because it is confusing as shit.
Oh,
So-
are you talking about like, so on anything iPro, that includes core link for the digital input, you actually have to have a transformer feeding 24 volts into there for it to actually work. Is that what you're talking about?
So this actually has a DI. So it's a true DI.
Oh, really?
Yes. So the way this works is like, if it's online with a network device, meaning like the E2 or something else, it has to have two different forms of enable. It has to have a networked enable and it has to have a physical enable.
Makes sense. Make sure nothing bad happens. I get it. Go ahead.
It's way overly complicated. Okay, because one is backwards.
Oh shit.
In the software, it's backwards.
Hold on. In the Visiograph in the
E2, like the description file does the enable backwards. So it has to be inverted.
Oh, for the DI.
No, that the DI, the software signal.
Oh. So if you're shit. Okay.
This is where it gets overly complicated and overly handled. Now, me personally, I think the whole enable is just ridiculous. Like, just get rid of it. It is not needed. You don't ever need to enable or disable that controller because it's going to do it on its own. If the rack shuts down and the flash tank starts to creep up, it's going to instantly slam those valves shut.
Okay, hold on. I want to tell you that you're wrong.
Why?
It shows here for every single digital input on RL4, RL2, because they have a low pressure, high pressure, general alarm, and then there's the shutdown alarm, and every single one is showing hooked up to 24 volt.
It's not the shutdown alarm.
What wires are hooked up to it then?
It's coming off the bottom of the controller, not the top.
Lame. Now you're gonna make me look for it. Go ahead, continue.
So the way this whole thing is, like, it's a little bit overcomplicated. Like, once you figure out that this particular customer seems to have it like down now, the EMS company, they've figured out the invert. So I mean, it's a little bit of overhandling it. That's the thing. Like that controller isn't needed to. You don't need to enable or disable it. Like, it's going to do it on its own. So like if there's a power failure or something like that, that valve's going to instantly close on its own because that pressure is going to start to creep up a little bit, and it's going to instantly shut the high pressure valve. It's going to do what it needs to do, and it's going to shut the flash gas bypass valve once it realizes that it's not doing anything. So it realizes it's in an emergency situation. So I mean, it's not really needed, but I mean, the one thing is they make it a little bit overly complicated. The other thing is making sure the scaling's right inside the Dixel. So you got to kind of play with it and make sure your scaling's right. And then the other thing is the step rates. So make sure your step rates with Dixel stuff, everything's in hundreds, not thousands. So if the step rate is 2,500, it's 250. If it's 4,200 steps or 203 steps, you can't do that. So it's got to be like 424, 423. Like you got to kind of like, you may be a step or two off. So that's one thing. And then if you're using, the manual's very, convoluted about this. If you're using a Danfoss actuator, so you're using that magnetic actuator, to drive the ICAD, to drive the high pressure valve, you have to tell it, there's 2 different AOs on there. You have to tell it AO1 is, or AO2, whichever you have it landed, is the high pressure HPV valve, or if it's the flash gas bypass valve. That way it's not trying to drive it off of the valve driver on the iPro. And then you have to assign that AO to it and tell it if it's 0 to 10 volts or if it's 4 to 20 milliamps. The first one we came out 4 to 20 milliamps, and it was throwing everybody for a loop because it wasn't set to 0 to 10 volts. So it wasn't, and then by the time it got caught, I mean, it was a problem. So, I mean, it needs to be set up for, 0 to 10 volts if that's what you're using instead of 4 to 20 milliamps. So that's one thing. I mean, they seem to get a little bit better. The description file is still a little rougher on the edges. You can't use the overrides on the screen, which is super frustrating. Like if you try to use the override on the screen.
Oh, you're talking about in the Visiograph.
Correct.
Yeah. So the only way you can actually do that is if you pull the 485.
Yes. And like if you try to override it in the description file, it doesn't work either.
See, I just found hold on, stop. I just found another shutdown and it has a transformer on there.
I don't know. Maybe they did. This fucking piss poor wire diagram in this rack didn't show a transformer. It just showed it as a digital.
No,
but,
I mean, after I read the 326 manual, I've had this one up like half the day. Sorry.
The 326 is way easier with that stuff. I mean, but like the description file and the Visiograph like set up, like it's that part is super frustrating that you can't force the valves, which makes it a nightmare because you can't pre-test everything.
Well, hold on. You can do that I'm pretty sure you can do it in the description file. Huh?
If you take the valve and put it down to 0,
yeah,
and put it back to 101, which is manual or automatic mode,
yeah,
it won't do anything.
Come on.
Nope, it won't change the AO for the high pressure valve. Same thing if you take that and you put the flash gas bypass valve 50%, it won't drive it.
Dude, I had the same situation happen when they were first putting all the ES1s for the Novars. And basically what happened was I was showing everyone and I was like, hey, look, you can do an override here if you go to this menu. And then I did an override to force the compressor to 100%. It was a digital compressor. I forced it to 100%, forced it to 0, and then I go to take it off to clear the thing, to clear the override, and it won't do it. It just stays at whatever percentage that I put it at. I'm like, shit. So I guess there's a glitch with Novar where it does that every once in a while.
It seems like some of the description files coming out lately have been like kind of, I mean, it's all code. So I mean, I
can't do it.
Yeah, me either. I mean, this is version 1. I mean, once it gets addressed and it becomes more of a problem, I mean, it'll get eventually, hopefully, taken care of. So, I mean, and the fact that you're trying to make something, that's a year old work with something that's 20, what's the E2, 21 years old?
It's not that old.
I mean, yeah, I mean, try, show me a 21-year-old computer that's still, trying to work with some new software, some new video game. It's gonna be rough. But I mean, the iPro is working, and it does seem like it's honestly a good off the shelf replacement, and they seem to have it. So like, if I was to lose one, I would probably go to that if I didn't have microthermal. Now, if I have a microthermal store, which we've already had this situation, I've already retrofitted 2 stores now to microthermal 2 valve controllers, and they work great.
No, you didn't.
What's that?
I said, no, you didn't.
No, I did.
I was joking.
Oh.
I was just breaking
now,
balls.
This is something I've been trying to get a hold of microthermal about. I want to know if that 2 valve controller is standalone, because like all their new 700 boards have Ethernet capabilities, and I'm pretty sure they have a built-in web UI. So I want to know if that controller, could be standalone without Alliance, and
Wait a minute. I thought all microthermal boards, like the suction control, condenser control, those can all work independently if they lose network, right?
Correct. Now, but you have no way to program them without Alliance.
Oh, well, I get that, but what I meant is like you could still, like it'll still run independently.
Yeah, but the problem is like if it were to like lock up, you'd have no way to reset it. So or see the values. So, but the 700 boards have an Ethernet port into them, and supposedly I'm assuming some sort of web UI or a programming interface that you could see. So I mean, that may be a viable option moving forward to change these, because I mean, we've already lost. I think we've lost 6. We've lost 6 Danfoss 326 controllers, and 4 of them were from shorted flash gas bypass valves. Because when the flash gas bypass valves, the Danfosses fail, the motors short out, and somehow it puts 24 volts to the controller.
Well, that's when you start going to have the discussion and put the fucking buffer in there to make sure it doesn't short that shit.
Well, it's the valve driver. It's the internal valve driver inside the board shorting on the 326.
No, but what I'm saying is if you had some kind of circuit that would basically shut that down, almost like a low voltage GFI, you know what I mean?
Yeah, I'm
really downfall, they would shut that shit down, and then it wouldn't take out the 326.
Yeah, I mean that's been a problem, and then all these racks outside on the roof. I absolutely despise racks on a roof because I mean, just like you do, I mean, it's hot, it's cold, it's wet. I mean, no matter how good an electrical cabinet's sealed, it's still going to get wet, especially when you have exhaust fans sucking out of the cabinet and you're creating a vacuum in the cabinet.
Never.
Yeah. So, I mean, we've had a couple of these and the manufacturers are mounting them on the doors. Like, this is the most important thing of the rack. And it's mounted on the inside of the door, electrical cabinet door, where the water is going to come in and drip down on it. I mean, this controller without this, I mean, the rack's dead in the water. If you lose a high pressure valve, say if you have an external driver, you lose a high pressure valve driver. Yeah, you can make it work with the E2 and some fancy programming and logic. I've done it, but I mean, if you lose that valve driver that's putting out the algorithm, you're done. You're dead in the water. You're not running that rack unless it's super cold outside.
I'm curious how you did it. That'll be another episode. You do that later.
But all right, guys, that's intro to flash gas bypass and high pressure valves. Thanks for listening, and see you in the next one.
See you guys later.